Hello everyone. In this video, I'm going to be going over how to create a siding track adjacent to an existing main line. So this will be a proposed track that we're going to try to mirror the geometry of the existing main line. I just want to clarify that I won't be discussing design standards or for um, the proposed track. That's really dependent on your specific um, design standards for your project. I will, however, use the Transport Canada design standard for track center and track clearances just as a starting point. And I'm going to use a number 20 turnout as kind of my turnout for the siding track. Um, to start off, we're going to need uh, a best fit alignment. If you want to know how to create one of those, you can refer back to my previous video on best fit alignments for railway track. So we need that, and then we're going to need a turnout block, whichever one you're using for your project. You can find geometry of a turnout block on various turnout manufacturer website or railway standards. So for this one, I'm going to use a number 20 turnout. It's going to be a right hand. So for this part, we want to align our turnout to our best fit that we created. So in my case, our best fit is the cyan line. And I'm just going to plop it down there, and I'm going to rotate it so that the bearing is the same as the tangent. You can also use the align command for this one. So just like that. And then what we want to do is we want to offset these best fit tangents by whatever track center we're going for. So if we look at our railway clearances here for Canada, um, between main and siding tracks, it's 14 feet. Um, and then if we scroll down a little bit more, we can see that between curves, for curvature and super elevation, for curvature, it's 2 inches per degree of curve of track. And then we're going to need another additional track center widening for super elevation, which we're going to ignore. I'm not going over super elevation in this video. So we will just use this and use the 14 feet. Actually, for this particular video, I'm going to use these 15 feet plus 2 inches um, just to make things simple. So in that case, for tangents, we're just using 15 feet, which is 4.572 meters. So we can, you know, offset all our tangents. So the siding's going to be on the north side of the track. Um, we can just offset all our tangents like that to start. I'm probably just going to do one of these tangents actually for this video just to keep it short. Otherwise, it's going to be like an hour long video. So we got that. And then, oh, the last thing is we also need a tangent off our divergent leg of the turnout. So we'll do that, and then we can use the fillet command. Select this and this. Oh, wrong way. Let's try that again. There we go. So we got this. The other thing we need to know is we're going to need to know the existing geometry. So I'm going to add some geometry labels here. Let's do this. I don't want curve midpoint. Yeah, so now we can see kind of where the curves are. And then we can start creating our proposed alignment. So we'll go here, alignment creation tools. We'll say, let's call this proposed siding center line. Yep, this is all good. Hit OK. I'll go here. So in creating alignments, I like to start a little bit more than I have to. So we'll start somewhere here. You can even start further back, but we don't have the best fit for back there. So start here, we'll go there, go here, there, and here. We'll stop there. So this lets us model two curves, the turnout curve here, and then we can do a spiral curve spiral here. So the turnout curve is pretty straightforward. We're going to use a 1.5 degree curve for this one. I'm just going to load up my spreadsheet. So I have this spreadsheet here that kind of helps me figure out, convert between degrees, minutes, seconds, and meters. So I'm going to put in 1 degree 30 minute. So that's 1164.283. So we'll do this free fillet curve 1164.283, just like that. And I'm going to actually add labels to this so we can see our uh, geometry points as we create this. So I'm actually going to make a copy of this one, and we can put flipped here so that it's on the other side. So the orientation is controlled by the line. So if I just rotate it 180 again, it should be the opposite of our main line. Oh, did I not add it? I did not. Let's do that. Remove curve, midpoint. There we go. So the green line here is our center line from survey. Uh, so you can get that from your surveyors, or if you don't have it, you'll have to create a new polyline which uses the center points between the 2 points. So we want to offset that 15 feet plus 2 inches per degree of curve. So first we got to figure out the degree of curve of this existing track. So if you go into here, so you can see that when I click this curve, it highlights this portion. So that is our current curve. It's 389.25, let's say. Go here, 389.25. So it's very close to a 4 degree 30-minute curve. So basic calculation, 2 inches per degree of curve, that's 9 inches track centers required. So we add 9 inches to 15 feet, that's 15.75. So let's convert 15.75 to meters, that's 4.8 meters. Okay, so we want to offset this 4.8. We'll go this way. And then what I like to do is just trim this off because this is really acting as a guide on where our curve needs to be. So I'm going to trim off this green line. So we want to make sure that when we create this curve that we're clear of this green line. If we're not clear of this green line, that means we're fouling the existing mainline track. And the reason I trimmed it off at the spiral is we can foul it at the spiral because it's transitioning, meaning you don't need the full 15.75. You need like 15.75 at this point, but you only need 15 at the start. So it's kind of a transition point there. So if you want to even make it more accurate, we can actually do this. So trim it off here. Let's delete that. And then trim this off. So there we go. We want to clear this green line. So let's get an idea of spiral lengths. So we got a 389.24 curve, and then we got 75, 120. So let's make this a little bit rounder. Let's make it exactly 4.5 degree curve. 388.183. Let's do that. So spiral, curve, spiral. Oh, it didn't select the first entity. Oh, I'm in the wrong. There we go. So what was it again? 388.183. So spiral lengths, I've already forgotten. So let's just put 50. 50. Okay, let's go back here. I'm just going to take a screenshot so I have this for reference. So it should have been 75, 120. Um, let's use that as a basis, as a starting point. So let's do 75 and 120. Okay, so you could see we're actually pretty good, but what you want to check for in this method is the vertices, because that's the actual survey point, but you can see here we're okay, we're on the other side. There we're okay. We're okay for the most part. Let's keep going. Oh, we're okay everywhere. That was, oh, here. So over here we're not good, so we're gonna have to adjust the spiral on this side. Let's try going to 90. 90 is good. Might be a little bit too big. Okay. Yeah, there we go. So we are good everywhere. Yep. So this is good. So now your track center is at least 4.8 meters in this. That's what this green line tells us. So therefore, we're not following the track. And so I just want to make it clear that we're adjusting the spiral lengths to suit our track center requirements. Sometimes your spiral length might need to be higher than 85 to meet your super elevation requirements or your train speeds and so on. In this video, we're not going over that, but I just wanted to make it clear to you that you would need to look into that. Another thing you should look at is your reverse curve tangents. In for the major railways in Canada, it's minimum 100 feet. Um, in this case, yeah, it's over 100 feet, 30 meters, so we're good there. Yeah, that's how you create a basic siding track. With this, if you follow this method, you should be able to create spiral curves all throughout this. All right, thank you for watching. Bye.